So I'd like to now ask you to welcome Greg Crutsinger to the stage. He is a university professor. He and I were seatmates at lunch, and he was regaling me with this stuff. And I think you're really going to enjoy this presentation. So it's, Professor, it's all yours. And you have a drone here, so I'll duck.
I do, thanks. So I should clarify that I am actually a recovering academic. So I've been sober of graduate students for about 3 years now. So I was a university professor, and I am trained as an ecologist. So my research was in plant-insect interactions. So I was interested in how the genetics and the environment of plants affect the suite of insects that really rely on plants and the ecosystem around that. And I was excited about using drones because we were planting giant trials and experiments, and I was hiring lots of field crews, and we were going out and planting hundreds of trees and plants and shrubs, and then we had to measure them all the time, right? So I had to measure like the size of the leaves and how tall the plants were, and it was all super tedious, and I thought that drones were a nice, exciting new answer that may replace some undergrads. And so that's really what I was excited about in getting used to drones. And so what is a drone? So this is a drone, so we'll just launch that up in the air. So a drone is like a remote control aircraft, only the difference is that we can program it to do cool things, like do flips. And it can do the same thing over and over and over again. And so we can just program it to be a robot. And I promised my wife that I wouldn't try and catch this in midair, but I totally could. And so the difference really is that they're smart, right? Remote control aircraft have been around for about 50 years or so. And so why are drones so cool and so trendy today? Well, I wanted to kind of walk you through the industry, of the drone industry that I'm in now in Silicon Valley. So I gave up academia. I gave up 10 years of work to become this assistant professor, and I left academia and my grad students behind, which they were okay with, and I joined the industry. So we moved to San Francisco, and I worked for a bunch of the leading drone, both hardware and software manufacturers, and now I started my own company, my own startup. But it really started in 2007, so with the launch of the iPhone. So about 6 hours north of here, Steve Jobs came out in his black turtleneck, and he launched the iPhone, which started the whole smartphone technology industry, right? And so we all have iPhones now, or other smartphones. iPhones are just fairly popular here in California. But with that movement came the miniaturization of a lot of technology that's used in drones today. So GPS, gyroscopes, accelerometers, everything that you use to play Candy Crush or other games on your phone are really what started with drones, along with miniaturization of the computers and the processing power. And so this led to a whole DIY movement, and these are my notes here, instead of having slides, that way you get glamour shots of drones. 2013 or so, this is what a drone looked like. So it's just a pizza box full of parts in here, and it was usually fairly geeky engineering types that would like to solder all this stuff together. That wasn't me, which is why I still have a box full of drone parts. But the key there was really the autopilot. So for $100, you have an onboard computer that's pretty much the same as what we would put on a cruise missile, but it had open source software on it. So programmers across the world could program drones, you could plug everything in, and something flew kind of okay. But you could program it to fly again and again. And then people started doing things like attaching really light sports action cameras. So there's a GoPro, it weighs about 100 grams, strap it to the drone, you get cool shots. So that then led the drone industry from 2013, 2014, 2015. It was what we call the bros and the joes, but it's all the dudes down at the beach that strap on GoPros and then fully integrated cameras to get cool shots. And that's what led the innovation in the industry from a several million-dollar industry to the billions of dollars of today, was strapping on cameras and then fully integrated cameras to change how we do storytelling. And that innovation then has led to the commercial market. But during that time, there was a lot of investment in hardware, and hundreds of millions of dollars of venture capital went into drone hardware, and then I worked for some of those hardware companies. From 2015 to 2016 or so, there was a bloodbath within the hardware industry. And a lot of those companies lost a fortune as DJI, the leading manufacturer out of Shenzhen in China, just crushed the entire market. And they did it by outpacing us in robotics and innovation, and they did it in just their manufacturing capabilities. And so now today's drones, this is about the same size as the toy that you saw, but this is a $500 drone that has a fully integrated camera. It shoots at 12 megapixels, 4K or so, and these cameras are getting even better. And it seems like a toy, but this is linked to my smartphone. I can go from an app to the controller to talk to the drone. I can program it. I can collect incredible imagery, and I can send it back to the cloud. This is the Internet of Things. This is Siri in a tiny little thing that I can buy at Best Buy or have overnighted from Amazon. This is what's changing agriculture of today. Now, I talk a lot about the consumer industry because that's really what the push was in the market, because it was illegal to make money from drones until June of 2016. That's when the FAA in the US came out with this. This is a great thing. This is my drone license. It cost me $200, and I went in and took a 60-question multiple choice test, of which I only had to get 45 questions right. And now I can use drones up to 55 pounds, which is huge, in my business every day. And so that we went from 1,000 drone pilots to 10,000 drone pilots to 100,000 drone pilots in about a year or so, all with this Part 107. So the laws now are available. As long as you follow some certain guidelines, you can use drones in your business. And this is what's really exciting about agriculture. We also are ramping off of what the consumer industry has built us in terms of hardware to add better sensors. So this is a GoPro-sized multispectral camera. So it's exactly the same size. They both weigh about 100 grams, but this is a 4-band multispectral plant camera. Instead of having red, green, blue color, we have different bands that plants care about, right? So we can measure red edge, near infrared, and we can mount this to a drone, and we can fly our fields every single day if we want to throughout the entire growing season. And I can capture imagery down to about a centimeter scale resolution depending on how high I fly. And so what that allows us to do is we can create amazing maps, and we can do things like plant indices, we can do our prescription maps, we can do stand counts, we can input it into our management software, we can, there's all sorts of different applications that people are really excited about and what they can talk about. And that comes at this super innovative time within ag, right? The digitization of agriculture. And so in parallel to all the innovation happening just in drones, we have all the innovation happening in agriculture. So this is a handheld weather station, but it's just an example and reminds me to say that we're interested in sensors in the ground, we're interested in sensors on the ground, so I can take all sorts of abiotic measurements with this. I can then have sensors in the low altitude sky like a drone. I can have sensors then on satellites that take imagery of the Earth every single day. And I can put all of this together into a single package that makes me more informed as a grower or as a business owner or as a researcher or as an organization than I've ever been before. So that's the excitement of it. So what's the downside? So I want to leave with a slightly realistic perspective of the challenges that we're facing. So the first challenge that we really face is that it's too much data. So when I trigger this camera, I get 5 photos at once, and when I fly, I get about 2 gigs of data, and then I can produce about another gig of maps from that, and that's just like a single 12-minute flight or a single battery. And so if I'm flying every single day of the growing season, I'm getting this backlog of data. And if I'm doing that across teams or across sites, that's really the bottleneck, is I'm just overwhelmed with data, let alone trying to upload it all to the cloud. And I'm in San Francisco area, and our internet's pretty good. But if you're in a rural area and you're trying to upload gigs of data, it's much easier to just FedEx a USB drive than it is to upload to the cloud. And so the challenge is really, how do we manage all of this data? The other challenge is, I have a packet of seeds here. This is some Swiss chard that I'm supposed to plant in our yard, but it's my example, is how do we then ground truth the data? So I can produce all these maps, and a lot of drone service providers can produce maps for you, but what does it all mean? And so we're behind in how we interpret the data. We're behind in how we correlate what we're capturing in the air and on the ground and how we put it together, and then how we look at just basic correlations on what the imagery relates. How does it relate to biomass production or yield or nitrogen content? And how does it do that for this variety versus that variety? And how does it do it in California compared to Iowa? And so having all those relationships sorted out, it's just a good time to be looking for an undergrad thesis project, is what I can say. The other aspect is then training, and that's really where our company, Scholar Farms, comes in. So how do we come up with standards? There are different drones flying with different cameras at different times of day, in different speeds, at different altitudes, processed with different engines. How do we come up with the standards? And then how do we scale that education? And so what we are trying to do as a little sliver of that problem, in 2 weeks, we're launching a masterclass for drone mapping for vegetation. So Scholar Farms, all we do is teach you how to map plants with drones. But we also have to update that course continuously. So every week or every month, we track the industry and we update the course. If there's new sensors, we'll test it out and we convey it within that masterclass. And it's a generic masterclass for just mapping plants. Some of it's ag, some of it's ecology, some of it's forestry. We're kind of pooling it all together to see where the market really leads us in that training. We also do custom courses for commercial audiences. So if you do have a large agricultural company, and you do want to scale your training or customize it to citrus or to vineyards or some other application, that's also something that we can do, is come and collect those data sets, apply it to an online or mobile-ready learning, and then broadcast that out. Because one of the biggest challenges is that our 4-year institutions and our 2-year institutions are way behind, and they can't actually keep up with the pace of the drone industry and the tech industry in general. So I'll conclude with just this one statement, is that in Silicon Valley, where I live, and there's lots of hoodie sweatshirts and t-shirts running around in venture capital money, they say that big data is the next oil. And I believe that. I think data is the next oil. But if we don't drill down and condense that and refine out some of the hype and some of the ego and some of that venture capital marketing money, and really drill down to decision making, then our well is a bust. So thank you very much.